Here we go, and today I would like to share with you about, I would say, more like an educational lecture. Nothing new, probably, nothing special for you, because I'm combining information from different sources about the interesting expressions of attacks on Android apps, attacks which look more or less, effective. We know that in Android apps we have a lot of vulnerabilities which are sort of like vulnerabilities of extracting information and things like that. It sounds pretty boring. You can get out information. You can basically extract any information. But here I would like to share about how applications may affect other apps. I think it's interesting. And if you'd like to begin to get a little bit more knowledge about mobile apps and Android apps, this would be a good starting point. So here we go. I'd like to share a couple of words about myself. I am the employee of alarm company. I'm doing pen testing and the security analysis. These are the links to my Telegram. You can write me, you can ask me anything. We have our own chat and channel. You can discuss different things, and the guys write in different questions, and of course email, which nobody seems to be using anymore today. Anyway, the scope of my presentation is the following. I would like everyone who would like to go back to this presentation would be able to understand it all without me and to sort of like refresh this material in any way you want. All the way to details or just simply to scan this presentation again. So I will upload this presentation on my Telegram channel, maybe somewhere else. You'll be able to get it from the conference organizers. And in descriptions, you will find a detailed description of what will be delivered today in my presentation, all the names and everything else. And also, while compiling my presentation, I did it in such a way that if there'll be any questions about any topic, I would give you a detailed answer. Now, as I will be sharing, I guess, to go with the flow. But in the future, if you want to get more knowledge about a particular topic, you can take the topic and go to description of my slides. There's a lot of information, hypertext and links and all, you name it. And I've given a spoiler. We're speaking about Android apps communication, apps intercommunication 2 plus, and I will be sharing about attacks techniques on this inter-app communication process. I'll give you examples. I'll show you a video of how it is all happening, shooting, running, and doing all sorts of things. And in the same way, I would like to give you an understanding of how these attacks happens. These attacks from app to app happen. But actually, I was questioning myself. I was asking many of my experts and friends, what are the models, attackers' models within Android system? I generalized it. I usually like two. It's an app and human. Human can get my phone number, do something with an app to extract something, or the app which has been installed and somehow it may affect my operational system. And as a part of this model of violations described in mobile security project, there is this kind of division, looks very interesting. And here we say not only like robot versus human, but also the human with what kind of rights and what kind of robot, be it a script, be it an app, be it a text message or something else. And I think that you can go to it if you want to work even with documents, or you can go to these kind of slides, or you can go to Mobile Security Project to understand who could be the initiator of these app attacks. Next, the tools. Like I said before, I would like to make this presentation as clear, as detailed, so that you'll be able to use it in the future, for the future reference. These are the tools for the checks and the attacks, double checks. Android Studio would be number one. It gives you emulator with a device, with an app, and you can play, you can attack, and different things. Secondly, Android Debug Breach. It's a tool, fixing tool. There is nothing really to compare it with, because it can do anything. It's very intuitive, great documentation for each flag. Whatever it's doing, you can figure it out. And number three is a Browser. It's a good app, and this app is playing as a client in a mobile device. That is, it's an external app that can do something. You can build this kind of browser client, and on behalf of the client, you you can play as the threading app. You have a server part, which is like playing this browser. Basically, it's like agent client, and the client would be the browser, agent would be your device. It's a very popular thing, quite simple for the matter. And so I split my presentation in two parts. Number one, I explain how it happens, why it happens, and how it looks like, how you can fix it, and things like that. I'm trying to explain it in a very simple common language. Hope you'll not get bored. And the second part is attacks. I will give demos. It's a real meat of my presentation, how it works with the video and why and everything else. What are we speaking about today? It's about activities, intents, and I'm going to share with you what activity is all about. I can see my friends and colleagues, they have no idea what activity intents is all about, so I guess I'm going to address them. Android app has several components which are part of this application, from each to each application. One of these components is activity. This will be the main screen, basically the screen of your app, a page, where you have certain operation going on. So basically, direct translation of this activity into operation. And by activity, I mean execution of certain action. You have the Sberbank application, for example, where you go to the main screen, you can see the main activity, which is giving you chance to authenticate. Then you go to activity to look for your amounts, your money transfers, etc., etc. These are the simple operations which can be split apart. Usually, the app consists of many activities. Any big activity or any serious application has several activities, not one. Like I said before, you have the main operation, which has been detected in manifest file. Then I want to show you how it looks like. And there are different descriptions of the activities lifecycle in Android system.
And the approach is that there's an event-based system. When something happens, we react on it, and all the applications are based on the fact of us creating a handler that has some code upon launching an activity or upon exiting an activity. So each and every activity, it can be a class in Java or a set of classes. They can be used or reused and so on. So to simplify for your understanding, activity can be represented as Java class with some functions like on create, on launch, on close, whatever. So when you announce or initialize the activity, Android system knows about all the activities of the application. You have a manifest file that regulates everything that can happen within an application, all its main functions that the Android OS needs to see. And the main one is activity. As I said, it's part of an application. It's in the folder with an application, and the activity has a name only mandatory parameter, which is the name of activity. You can also add other attributes, external attributes to an activity that help us simplify the communication between applications. We will consider them a bit later. Okay, let's move on. For you to understand an activity, the operations that you have on the screen of your PC are not very simple in the sense that you can interoperate with them through other applications. It's an inter-process communication. You can call the activities of other applications. You, for example, you know the Yandex Transport, you book a car, and then you move to Yandex Drive, and where you manage the car rental. So you called one application from an activity of another application if the activity complies with some conditions. One condition is an intent filter, an option for external applications to call your activity. So you need to describe that intent filter as part of your manifest file. I'm doing a little bit of an abstract overview, but give me a moment and we will go into details. So this activity can be called, I will describe an exception, but in general it can be called by any external application. So for some activities, you don't need to put this filter because activity besides showing you some information, also launch some actions, especially if you add an export attribute. If you want the intent filter to work only with your own application, then you set an export to false, and now nothing else can uh, trigger this activity. If you don't send false, then any activity can trigger it if the intents are the same. So intent is the direct mechanism for inter-application interoperability, and the applications in Android can send messages to each other to run something. For example, an application can send an intent to open some other application like Yandex Drive opening page, or run a service, another component like music, file download, things like that. So if this service is exportable, then the other application can uh, launch it. And it's not recommended because the user cannot monitor it. They're running on the background, and any application will be able to launch this service for downloading files and so on and so forth. And to send broadcast messages also. It's one of the mechanisms for Android applications is like broadcast receivers, the servers that enable you to subscribe to some events, like battery level. The battery is 15%, is sent to the whole system, and all the applications that are subscribed to those messages and events will receive it. And a lot of applications can generate a lot of messages. All those IPC things, they create a lot of vulnerabilities, of course. And this is what we will be talking about. Some more details about intents. It's not so that simple. As I said, you can trigger this from other applications, but you need to take into account some things, and I will tell you more details now. So there are two types of intents: direct intent and indirect intent. The direct ones have some are triggering some specific class, like in your Sberbank application, you have a screen with your balance, and to call it, you specify the class or the Java class of this object, and you address it. You can get all the exported activities, of course, if the exported flag is true. Then you can put this part of code in your application and call the intent, sending the download service to it. You have URI here. To it, you have URI here, and you start the service. And the most interesting part is indirect intent. It's when you address not to some specific object or operation, but but a request to handle some interaction, like open PDF. And every application that can do this will be proposed to run this. You see this when you open PDFs. So you have all the applications that you can use to open it. So one application launched an indirect intent with open PDF action, and 3 applications are signed up for this, and they say they can process it. So they're shown to you as options. If it's only one, then it's open. But the calls, like for the calling the numbers, you usually open it through a phone app, But if you have two applications like with Skype, you will have two of them. Of course, if you specify the intent directly, then there's only one application uh, running it, and indirect intent without any data sent, and then you give it an action, like action send, some action for sending a message or some data. So some extra parameters. It's another feature of those intents. You can send some parameters, send some data, and they can affect the logic of executing the application. And then you start activity and uh, launch some activity. The same will happen when you want to launch some service or drop a broadcast receiver. So how does Android OS react to direct and indirect intent? With a direct one, we've explained it. With an indirect one, it throws a request to the system to process it. And what is important here is that direct intent don't actually save you or protect you from vulnerabilities here. Because if you have an object that runs some malicious activity, then you can launch it with both the direct intent and intent filter. And it shows which actions need to be done for the operating system to process the intent. Let me check that I did not forget to mention everything that's on the slide. So if the activity here is not exported, and even if we mention it directly, we cannot launch it because it's not exported, and it cannot be launched by another application. Just a reminder here for the developers and experts, component access restriction through intent, we can define it for this specific action. Say it needs two parameters of data in the category to launch. Such filters do not provide for security. You can limit the choice, but every time you define that filter without saying exported is false, you always provide an option for this component to be called. And here's an example of attack. We'll work with specific attacks here. I hope you understood there are IPC processes, some services that you can attack, and give you some examples of in the wild attacks and where we saw them. First example is attacks on exposed activities with export flag true or intent filter that allows them using some intent to launch using some intent. On the left, there's an example of secure bank v2, insecure bank v2, which is a breach to emulate vulnerabilities. I don't know anything that would look like a real banking application. You don't need to create some specific abstractions to work with it. And the vulnerabilities are there. You just, you need to go find them and exploit them. So here we have an activity with the export flag true, meaning every application can launch it. Below is an explicit intent, so you don't have an intent filter, which is used only when it's inexplicit intent. Here we only have an application class We have the full name of this activity. We can address it using our Android debug bridge. We run shell, and Android has a tool, a service called Activity Manager, AM. AM start launches the activity and means it should be explicitly called, then the name of the class that processes this activity, then -e is an extra string parameter you name with the name Jack. Then we see that the activity was launched. Here we have logging. We can address the activities that are responsible, the view statement activity that is responsible for balance. Then we close it. I launch the ADB shell abstract code. It's on the screen and it works. If we have extra privileges, we can read what was there on the screen, and if there were some actions, then we can call it and run those actions. Let me show you a vivid example of such an attack. There's an article by Adam Gazette of intent spoofing in Android. He worked in Google security team, working with Android applications. They took 500 popular applications, filtered them, and they saw a PayPal application allowing the users to send money within the system. But it had a vulnerability. The activity for money sending interface was exportable, and any application could trigger it and show the user the screen with its balance. It also allowed for the string parameters to be sent, like from whom to whom, how much. So an external application installed on this device could launch this screen, fill it in with data they needed, do anything. But if we run this trick on 10,000 devices, a significant portion of these users will press the big red button send. It will have a small cancel button on the left, and in the center it will have a big red send. So it's a social engineering feat, and it was met in the wild. And there's a lot of other examples of activities launching other actions. Next one, intent sniffing attack. We can drop some intents into the system, but also there are intents that are responsible for sending the intents to broadcast receivers. So when we would like to run this intent so that all broadcast receivers get this information, we need to run broadcast intent. In Android system, every application that is subscribed to this broadcast intent will receive this information. And here, an example from Insecure Bank v2, we have a receiver, a broadcast receiver, which is subscribed to the broadcast event. It's exported, so it can get some data, and the application can send it to its way some data. And there's intent filter, which expects that with this action the broadcast receiver will receive it and run some actions. On the right, there's a code for an application sending the phone number and the password to send the user the updated password information. So the application works with password updating using broadcast receiver. So how do you run this sniffing attack? It's a great video here. The only issue is I need to run it So here I log in into the application, enter some data, launch the browser, and emulate the foreign application. Run sniffing module and specify the action I would like to listen to. So I showed it, and now I need to launch the password change activity that changes it. I press change password, and everyone who is subscribed to this event gets this data. Well, it's not a very serious example. I don't think everyone changes their passwords through broadcast, but there are in the wild examples of showtimes, for example, when you use the search, the intent to update the showtimes applications was published, so you could listen to all of them, and other applications could listen to what films you are looking for. Ads, conversion. Unfortunately, even though those attacks are popular and interesting, there's not many good examples of those. And yeah, my next step would be to maybe create some good examples. But I'm too lazy to make it happen. Anyways, worth trying. Next type of attacks, it's intent injection attack. We saw it a little bit earlier. It's an ability to call some intent that the applications are subscribed to. So you can generate intent or choose intents that you can address from the other applications. So here's the same broadcast that we saw earlier. We saw how the application works with it, and now we can make the application run those actions by dropping our own intent to change passwords. So to the left you see intent injection, and to the right you see a code, simplified code that runs when you receive an intent. To run this, you need to send a phone number, string attribute, and a new bus. When you send it, it checks that the phone was sent, and then the password is changed. And so let me show how it's run. Live example. We have an application. I log in. I just check that my password works. To the right is a console. Let me check if the view state is running. I describe the intent here, and I change the password, and I add 2 string parameters, run it, and now I see the information received about the password changed. So I see a message here that launched the broadcast receiver and changed the password from old one to new one. All those types of attacks, they are quite vivid, and you see that the applications interoperate and can attack, and Android has a lot of examples of inter-processor collaboration, interoperability, and by the way, Apple does not have any of those. So you can also exchange data between applications, and a good review of Yandex mobile application team has just provided on their conference. Same with vulnerabilities is the Android advantage of when you protect the external perimeter. I'm not a big Android fan or guru, but I'm just interested in this topic. I'm really more doing web application protection. And the reason why I went into Android is because pretty much every service has Android client which works the same as a web application. And developers are well adapted to web vulnerabilities. They have checks for everything, but not for Android. Android had a slogan was security through obfuscation. So Android developers think that it's hard to reverse engineer Android systems. You can even obfuscate it further, and they build the security based on this. And every time I run some infrastructure protection, I actually look for an application and uh, uh, we
And these attacks give quite a big profit. I was studying several projects and I found some things which are crazy. If you go to your regular web, you can see like, okay, if you cannot, it's very complicated, you cannot do anything. But in Android, like send your data, choose on where the data flies off. It says admin false. Like they've written in the app in such a way that this JSON is flying off with all your attributes, including the attributes of whether you're admin or not. And you're like, okay, admin true. Okay, you're admin. So things like that are plentiful. So it's very interesting. I've left on the screen materials that you can dig into to really dig deep in this like inter-process interaction in Android, activity intense. You can read more of how it's working, why, and all that. Number three is how to test it. And I think this is the only one, not even the only one. There are different materials for testing, but at least it's one of the biggest, one of the most solid. It's getting old, but it's being updated all the time. And number four would be the description of all these vulnerabilities and attacks. Attacks on the project. There's a good description of what kind of vulnerability it is and how you can catalog it. And that's it. Thank you for your attention. My time is up. 30 minutes, I believe. So basically, that's it for me. I'm almost done. If you have any questions, I'll be very happy to answer. I'll be happy to communicate with you and to share whatever you'll find interesting on the sidelines of this conference. Thank you for staying with me and listening.